Good morning. Now, in today's session, we will learn about Fourier Transforms. So, we have completed Fourier series, Fourier Integral, and finally Fourier Transform. Okay, now suppose that f of x is a periodic function of x, then we know the Fourier integral of f of x can be written as f of x equal to 1 by root of 2 pi minus infinity to plus infinity e raised to I omega x g omega d omega, where this g omega is 1 by root 2 pi minus infinity to plus infinity f of t e raised to minus I omega t dt. So here this function g omega, this is called Fourier transform of f of t, and f of t is called Fourier inverse transform of g omega. So here you can write, instead of this x, you can write t also. So suppose that this is f of t is equal to 1 by root 2 pi minus infinity plus infinity e raised to I omega t g omega d omega. Okay, so in that case g omega is the Fourier transform of f of t, and f of t will be the inverse Fourier transform of g omega. Okay, so here you can either use f of x or you can use f of t. Okay, now equation 2, what this is actually doing is that this equation 2, it transforms time function, this is f of t, this is a time function, into an equivalent frequency function, okay, g omega. Whereas what does equation 1 do? It just does the reverse of equation 2, that is, it transforms the frequency function g omega into an equivalent time function. Okay, whereas equation 2, it converts or transforms a time function f of t into frequency function g omega, whereas equation 1 transforms a frequency function g omega to time function f of x or f of t, that you can write. So if you use f of t here, you have to write here e raised to I omega t. Okay, so g omega is the Fourier transform of f of t, and f of t is the inverse Fourier transform of g omega. Okay, now we are going to find the Fourier Sine transform and Fourier Cosine transform. Now short form for Fourier transform we can write it as ft. Okay, so we have found what Fourier transform is. Now we are going to find the expression for Fourier Sine transform and Fourier Cosine transform. Okay, both finite cases, that is finite Fourier Sine transform and finite Fourier Cosine transform. Now Fourier transform of f of t, you are just repeating the same equation just discussed above, that is g omega equal to 1 by root 2 pi minus infinity plus infinity f of t raised to minus I omega t dt. Okay, now you are splitting this minus infinity to plus infinity as minus infinity to 0 and 0 to infinity, and rest everything is kept same. Then 1 by root 2 pi is kept as such. Then here instead of this f of t, we are replacing it with the f of minus t, that is f of t, you are replacing it with f of minus t, assuming that f of t is even. This function is kept as such. So equation 3. So once again note, f of t will be f of minus t if f of t is even, and it will be minus of f of minus t if f of t is odd. Now from equation 3 we know your LHS is g omega, right? So g omega equal to 1 by root 2 pi 0 to infinity, 0 to infinity is written here. Now here f of minus t it will be equal to f of t if f of t is even. Okay, so you can write instead of this f of minus t as f of t itself. So what will be this equation? It is repeating, right? F of t raised to I omega t, f of t minus e raised to I omega t. So f of t is common, we can take it out, and what remaining is e raised to I omega t plus e raised to minus I omega t dt. This is the case when f of t is even, and for odd function what will be it like that? It will be e raised to minus I omega t minus e raised to I omega t. Okay, here just note a difference. Here instead of writing e raised to I omega t minus e raised to minus I omega t, they are reversing the order. This comes first and this comes last. Okay, just keep in mind. Now the above equation, this one, f of t is even, right? So 1 by root 2 pi is kept as such. Now this whole thing will reduce to 0 to infinity is kept as such, integration is kept as such. F of t e raised to I omega t plus e raised to minus I omega t is 2 cos omega t dt. Why? Because you know cos theta equal to e raised to I theta plus e raised to minus I theta by 2. Okay, here your theta is omega t. That is the formula that we have used here. That is the case when f of t is even. Now what will be the case when f of t is odd? It will be, see here it comes 2 by I. How does that come? Actually, if this is like e raised to I omega t minus e raised to minus I omega t, we can write it as 2 I sine theta, right? Why? Because e raised to I theta minus e raised to minus I theta by 2i is equal to sine theta. Okay, so but here if this is in this order, then you can replace it with the 2i sine theta. But here that order is reversed, as I already said. This comes first and this comes last. So in that case, you will have minus 2i sine theta. Now in order to remove this minus sign, you have to multiply and divide with I. So it will be 2i square sine theta with I square minus 1. So it will be 2 sine theta by I. Okay, that is what written here, 2 sine theta by I. That is why I comes as denominator. Now 5 is called infinite Fourier cosine transform and 6 is called finite sine integral. No need of remembering this name. I will tell you the formula that you have to study. You have to study these two formulas. That is 5, that equation 5 that we have discussed above is nothing but Fourier cosine transform, that is GC omega. C stands for cosine. Okay, so the formula for finite Fourier cosine transform is root of 2 by pi 0 to infinity f of t cos omega t dt. Equation 7. Now the formula for finite Fourier sine transform is GS omega. S stands for sine equal to root 2 by pi 0 to infinity f of t sine omega t dt. That is equation 8. So here also I am telling you once again, no need of bothering about all these derivations. Okay, because from the exam point of view, you will be asked only to solve problems. For that, one thing that you have to keep in mind is the important formulas that you come across while doing derivations. The one such formula is this one, that is finite Fourier sine transform, this formula, then finite Fourier cosine transform, this formula. So these two formula you have to study because it is likely to get applied while you are doing problems. Okay, so this is finite Fourier sine transform and finite Fourier cosine transform. Now we are going to find its inverse. that is inverse of finite cosine transform and inverse of Fourier sine transform. These are given by equations this one. See. Okay. These are the inverse of Fourier sine and cosine terms. So here, as already discussed, you can study this formula also, the inverse form also, 9 and 10. Okay, now just you compare. Here, equation 7 and equation 9. They are actually stands for cosine terms because both are C. Okay, so equation 7 and 9 stands for Fourier cosine transforms. This one represents finite Fourier cosine transform and this represents its inverse, that is inverse Fourier cosine transform. Now equation 8 and equation 10 stands for Fourier sine transforms because yes. Okay, equation 8 is finite Fourier sine transform and equation 10 is its inverse, that is inverse Fourier sine transform. Okay, so you have to study the formulas 7, 8, 9 and 10. Then so this 7, 8, 9 and 10, all these things mainly represents the finite series and its inverse. Now when it comes to infinite series, that is infinite Fourier sine transform and infinite Fourier cosine transform, then the formulas will be like this. Inverse. Equation 11 represents infinite Fourier sine transform. Equation 12 represents infinite Fourier cosine transform. Okay. Now its inverse. This is the inverse of infinite Fourier sine transform. This is the formula for inverse of infinite cosine transform. So you have studied 8 equations. First 4 set of equations represents finite Fourier sine and cosine terms and its inverse. Now these terms, the next 4 set of equations represents the sine and cosine Fourier transform of infinite series and its inverse. Okay. So we can learn all these equations 7, 8, 9, 10, then 11, 12 plus these 2 equations, it is inverse also. Okay, hope it is clear, that is which all formula that you have to learn. This is finite Fourier sine transform and this is finite Fourier cosine transform, its inverse. This is finite Fourier sine transform, its inverse. Okay, so 4 set of equations. All these are of finite series. Now another 4 set comes for infinite series, that is infinite Fourier sine transform, its inverse, infinite Fourier cosine transform, its inverse. Okay, now here this infinite series is of least importance. So you, when you study, you give more importance to this formula, that is finite Fourier sine and cosine transform and its inverse, that is these 4 equations 7, 8, 9, 10. Okay. Now we are going to find Fourier transform of a derivative, that is if you have a function, then what will be the Fourier transform of the derivative of that function. Okay. So we already know g omega, which is nothing but Fourier transform of a function f of t, is given by 1 by root 2 pi minus infinity to plus infinity e raised to I omega t f of t dt, right? That is your g omega. Now what will be its derivative? So g omega will become g1 omega, that is first derivative. 1 by root 2 pi is kept as such, minus infinity to plus infinity is kept as such. In g omega, here you are having f of t. Since you are taking the first derivative, in place of f of t, you have to write df by dt. E raised to minus I omega t dt is kept the same. Okay. Next is simple integration. You are integrating it by parts. 1 by root 2 pi is kept as such. Then this one, first function into integral of second minus integral of derivative of first into integral of second dx. On applying this equation, you will get the final form as this, g1 omega equal to this one. Here g omega is the Fourier transform of f of t and g1 omega is the first derivative of f of t. Now in this equation, when t tends to 0, e raised to I omega t becomes 0, and as t tends to infinity, then e raised to minus I omega t will be infinity. So this expression or the first derivative of g omega, that is g1 omega, can be written as I omega into g omega, that is Fourier transform of f of t into I omega will be the first derivative of g omega, that is g1 omega. So this is a formula. g1 omega is equal to I omega into g omega, where g omega is the Fourier transform of f of t and g1 omega is the first derivative of the Fourier transform of f of t. Okay, in simple words, you can rewrite it as f of t df by dt equal to I omega f of t function f of t, that is Fourier transform of the first derivative of the function is equal to I omega into Fourier transform of f of t. Okay, that is the formula. So remember this formula, these two. This one is the same as this. You can learn any of these two. Okay, that is g1 omega equal to I omega g omega. That is g omega is the Fourier transform of f of t. Okay, that g omega into a factor I omega will give you the first derivative of Fourier transform of f of t, which is nothing but g1 omega. Now we can replace it with integral. 1 by root 2 pi is kept as such, minus infinity to plus infinity df by dt, that is the first derivative of, instead of f of t, you are writing df by dt, the first derivative. E raised to minus I omega t dt is the same as I omega into Fourier transform of f of t, which is nothing but g omega. What is it? 1 by root 2 pi minus infinity to plus infinity f of t e raised to minus I omega t dt. So these three equations, when you analyze, are the same. This one is the same as this one. Again, this is the same as this. But this one is written in various forms. This equation is a fundamental equation. It can be written either in this form or in this form. All these three equations means the same. Now, in this above equation, just replace f of t by df by dt in both sides of equation. Then you will get what? We are multiplying. So this will become d square f by dt square. Rest everything is kept as such. Here df by dt e raised to minus I omega t dt, which is nothing but I omega the whole square g omega. So that means you are now obtaining the second derivative. See how the formula changes from the first derivative. Compare these two equations. This is the first derivative formula to find first derivative, whereas this is the formula to find second derivative. The only change is that I omega, when you find second derivative, it becomes I omega square. In the first derivative case, here it was df by dt. In the second derivative case, it is d square f by dt square. In first derivative case, here you have I omega, but in second derivative case here you have I omega the whole square. F of t, is Fourier transform of t is kept as such. Okay. So now if this is of n times, then what will be the nth derivative? In place of 2 you write n, in place of this 2 you write n, rest everything is the same. See. Okay, so that is the derivative calculations. G1 omega equal to I omega G omega. Now if you are using second derivative G2 omega, it will be I omega square G omega, right? If it is nth, we will write it as raised to n. Okay, that is only difference. Now, so here we have discussed about the Fourier derivatives, Fourier transform derivatives in general. Now we will look into the Fourier transform derivatives for sine function and cosine function. Now this is of least importance. You just go through this. Okay, if you want, you can study the formula. Fourier sine transform, this we have already discussed. Fourier cosine transforms expression also we have discussed. Now here Fourier sine transform of first derivative of df by dt is given by this one. Okay, G1s omega. What does that mean? 1, when you see, you can know that it is derivative. S stands for sine, so it is 1 stands for first derivative, S stands for sine. So from this G1s omega you can say it is the first derivative of sine Fourier transform. It is given by this equation. Now on applying all these conditions as before, you will reach the final formula of G1s omega, or the formula for first derivative of sine transform as minus omega Gc omega. That is the formula. So this we can learn. Next, about cosine term. This is the formula. First derivative of cosine Fourier transform is given by this equation, and on simplifying it reduces to a form like this. Okay, so these two you can study. So give more importance to this equation. Okay, this one. This is the formula that you have to study to find first derivative of sine Fourier transform. Okay, so when you are asked a problem, you can apply this equation. The next formula that you have to study is this one. The formula to find first derivative of cosine Fourier transform. So you got two formulas. So from this whole derivation, you just study these two formula. That is formula to find first derivative of sine Fourier transform, and formula to find first derivative of cosine Fourier transform. Okay. Now what will be the second derivative? Instead of G1c omega, what will you write? It will be G2c omega. That will be the second derivative of cosine Fourier transform. Its equation is this one. That is second derivative of sine Fourier transform. Then formula to find second derivative of cosine Fourier transform. Okay, second derivative and all is not normally asked. Okay, so if you want, you can study this formula. As I said before, you can study this formula, that is for second derivative Okay, for second derivative, I think it is better to learn this formula. Minus omega square gs omega plus root 2 by pi omega f of omega. Okay, now this is the second derivative. So actually give more importance to first derivative. Second derivative I have given only for your reference, that you can skip. Okay, no need of learning more on second derivative because problems and all are not asked. If you are interested you can learn, otherwise you just skip, but learn first derivative very well. That is the formula: first derivative to find Fourier sine transform and first derivative to find cosine Fourier transform. Now second derivative I have presented the results just for your information. If you are interested in learning second derivative also, you can go through the steps. That's why I have given here. Okay, but give more importance to first derivative of Fourier sine transform and first derivative of cosine Fourier transform. Okay, learn the formulas. Now, as I already said, from these sessions and all, you will be asked only problems. That is, one such problem is you are given a function, say n into e raised to minus alpha x square. That's your function, and you are asked to find the Fourier transform of this Gaussian distribution. So first you write the formula that you have learned. What is your Fourier transform? G omega equal to 1 by root 2 pi minus infinity plus infinity f of x e raised to I omega s dx. In place of f of x, you substitute the function that is given in the question. Then you group all these terms, get like this. And now here they have done something in order to bring that equation to a particular form, that is n by root 2 pi is kept as such. Then e raised to minus alpha, they have taken it outside, and what is remaining inside the bracket is x square. Then minus alpha is already outside, so second term will be I omega x by alpha. Then only it will be the same as e raised to minus I omega x, right? Plus they are adding a term, omega by 2 alpha the whole square. Since you are adding such a new term, you have to multiply it with that term itself, that is into e raised to alpha omega by 2 alpha the whole square. Because since you are introducing a new term here, you have to multiply the equation with the same term. Okay, now this is kept as such. Here this is integral. This integral is applied to this term, dx is kept as such. Now this one reduces to a plus b the whole square. That is, here in place of a you have s, in place of a you have x, then in place of b you have omega by 2 alpha. Okay, so this is of the form a plus b the whole square. So on simplifying, you will reach at this expression, e raised to minus omega square by 4 alpha. Okay, then this is kept as such. In place of this one, x plus I omega by 2 alpha, replace it with y, so it will be y square. Now integral, this one is kept as such. Integral of this form is root of pi by alpha. This is a standard form, minus infinity plus infinity e raised to minus alpha y square dy is root pi by alpha. Okay, so that is substituted as such here. Finally your result will be like this. Now the last question, find Fourier transform of e raised to minus t. Again, first start from the formula for g omega. Split this integral minus infinity to plus infinity as minus infinity to 0, then 0 to infinity. Use your function in both cases. Here, in the first case, you write instead of e raised to minus modulus of t as e raised to t, whereas this one, you write it as e raised to minus t. That is done in order to bring the equation, or in order to reduce the equation to a particular form. Then this is kept as such, minus infinity to 0. Here take the common term outside, which is e raised to t. The rest is grouped. Here similarly, here also. So you'll get this expression. And after that, 1 by root 2 pi is kept as such. Apply integration to this term. So you will get this. Again 1 by root 2, root of 2 pi is kept as such. Integrate this term. So you will get this one. And on simplifying, you will get it like this. 1 by a minus b plus 1 by a plus b, which is nothing, 1 by a square minus b square. So on simplifying, you will get it like this. 1 by root 2 pi is kept as such. So the final answer is root 2 by pi 1 by 1 plus omega square. So all these are integration. So you just work it on in your own way. Then you look at the steps and finally check your result with my result. Okay. So here work out more problems, as much as problems that you can. Don't get bothered about all the derivation part and all that we have studied earlier. Just study the important formulas that I have asked you to learn while teaching this class. Okay, because that will help you. The second derivative you can leave. Okay, only if you are interested you can go through, otherwise you give more importance to finding first derivative and all. And along with this class, I will upload a PDF file containing a few questions to find the first derivative of Fourier sine transform and first derivative of Fourier cosine transform, etc. So when I went through those problems, it doesn't seem very complex. It is simple. You will understand. I have written all the steps, so I will upload it as a PDF file for your reference. So please work out those problems also. Okay, so for today this is enough. Thank you.